This is Chapter 11, Part 5. The prescriber ordered 1.2 grams per meter squared per day to infuse over 30 minutes. Repeat for 5 consecutive days. The IV solution strength is 50 milligrams per milliliter. The patient has a body surface area of 1.50 meters squared. Find the flow rate in milliliters per hour. Okay, I'm going to start off with the BSA, 1.50 meters squared. I put this over 1, and I'm going to multiply it by this so I can simplify. 1.2 grams per meter squared per day. Well, the meters squared cancel, and if you multiply 1.5 times 1.2, you get 1.8 grams over 1 day. Okay, well, this is day, but really it's supposed to be over 30 minutes. Okay, so really what we have is 1.8 grams per 30 minutes. Okay, so now I'm supposed to convert this into milliliters per hour. So let's convert this. I have 1.8 grams over 30 minutes. There are 60 minutes in 1 hour. Minutes cancel. 30 divided by 30 is 1. Divide this by 30, it's 2. 1.8 times 2 is 3.6 grams per hour. Okay. Now we want milliliters per hour. We've got the hours. We just need to find a way of turning grams into milliliters. The IV solution strength is 50 milligrams per milliliter. Okay, so let's convert this to milligrams. In each 1 gram, there are 1,000 milligrams. Okay, so grams cancel out. If you multiply 3.6 times 1,000, you get 3,600 milligrams in 1 hour. Okay, now we can use 50 milligrams per milliliter. I'm trying to get rid of milligrams, so I put that in the bottom and put 1 milliliter in the top. And you do 3,600 divided by 50, and you get 72 milliliters per hour, because milligrams canceled out right here. And that would be your answer. Okay, so let's look at 11:13. A patient weighs 80 kilograms and must receive a drug at the rate of 0.025 milligrams per kilogram per minute. How many milligrams per minute should the patient receive? Okay, well, the patient weighs 80 kilograms. I'm going to put this over 1, and I'm going to multiply by this, 0.025 milligrams per kilogram per minute. Okay, kilograms cancel out. If you multiply 80 times 0.025, you get 2. So this patient gets 2 milligrams per minute. We want in milligrams per minute, so that part's done. How long will it take for the patient to receive 50 milligrams of the drug? So we start off with 50 milligrams. And we can use this. Okay, so I'm trying to get, this is over 1, and I'm trying to get rid of milligrams, so I'm going to put the 2 milligrams on the bottom and 1 minute in the top. Your milligrams cancel out. You end up dividing 50 by 2 to get 25 minutes. So it'll take 25 minutes to complete giving that drug. Okay, number 14. A patient must receive a drug at the recommended rate of 15 milligrams per kilogram per, I think that's a day, it got cut off by the picture. If the patient weighs 100 kilograms, how many milligrams per day must the patient receive? Okay, so I start off with the 100 kilograms. I'm going to put this over 1. Okay, and I'm going to use this rate, 15 milligrams per kilogram per day. The kilograms cancel, and you end up with 1,500 milligrams per day. Okay, and that's what we're asked for, milligrams per day. Okay, so the drug is to be administered in 200 milliliters over 60 minutes. The vial contains 1.5 grams of the drug in powdered form. This vial is used with a reconstitution device similar to that shown in this figure. Find the IV flow rate in milliliters per hour. Okay, well, to find flow rate, it's always the volume over time. So this is 200 milliliters over 60 minutes. Well, I've got milliliters per hour, and there are 60 minutes in 1 hour, and this whole thing cancels out. So in milliliters per hour, it's 200 milliliters per hour. I mean, you could have gotten this very quickly just by saying, oh, well, 60 minutes is an hour. I'm going to substitute it. No big deal. Okay, so part C. How many milligrams per minute will the patient receive? Okay, well, the patient is getting 1.5 grams over 60 minutes. We want milligrams per minute, so I need to change grams into milligrams. So I'm going to put 1 gram in the bottom and 1,000 milligrams in the top. If you multiply, you have 1.5 times 1,000 is 1,500 milligrams over 60 minutes. Okay. And here the grams canceled out. And then do 1,500 divided by 60, and you get 25. So this patient will get 25 milligrams per minute. Okay, so let's look at number 15. A patient is to receive 150 milligrams of a drug in 200 milliliters over 1 hour. The vial of medication indicates a strength of 75 milligrams per milliliter. How many milliliters must be withdrawn from the vial and added to the IV bag? Okay, so the patient is supposed to receive 150 milligrams of the drug. Okay, the strength is 75 milligrams per milliliter. So it's 1 milliliter over 75 milligrams. The milligrams cancel out. And we multiply straight across, or 150 divided by 75 is where you're going to end up with, which is 2 milliliters. So we need to withdraw 2 milliliters from the vial, and we're going to add it to the IV bag. Okay? Part B, at what rate in milliliters per hour should the pump be set? Okay. Now, we are supposed to put these 2 milliliters into a 200 milliliter bag. So now we have 202 milliliters to dispense, because it's the 200 that was in the bag already, and then we added 2 more milliliters to it. The flow rate is always, so we have milliliters an hour. So what we have is 202 milliliters, and it's supposed to be given over 1 hour already, over an hour, and that will be our answer.